Mars. The very name conjures images of a rusty-hued world, a planet that has fascinated humanity for centuries. A celestial neighbor shrouded in mystery, Mars has always been a source of intrigue and wonder. For centuries, we have gazed at its reddish glow in the night sky, wondering about the secrets hidden beneath its surface. The allure of Mars has inspired countless stories, myths, and scientific inquiries. Is there life on Mars? Was there ever? These questions have captivated scientists and dreamers alike, fueling countless missions to explore its alien landscapes. These questions have captivated scientists and dreamers alike, fueling countless missions to explore its alien landscapes. From the early telescopic observations to the sophisticated rovers and orbiters of today, our quest to understand Mars has been relentless. What we have discovered so far paints a picture of a planet both familiar and strange. Mars, with its vast deserts and towering mountains, is a world of extremes. Vast plains of volcanic rock stretch across its equator, remnants of a once fiery past. These plains tell a story of a planet that was once geologically active, with volcanoes that erupted with immense force. Towering volcanoes, some of the largest in the solar system, rise from the Martian plains, silent giants frozen in time. Olympus Mons, the tallest volcano in the solar system, stands as a testament to the planet's volcanic history. And etched across its surface are the scars of ancient floods, hinting at a time when water flowed freely on Mars. These dried riverbeds and channels suggest that Mars may have once had conditions suitable for life. Understanding how Mars came to be, from its fiery birth to its current desolate state, is key to unraveling the mysteries of our solar system. By studying Mars, we not only learn about the red planet itself, but also gain insights into the history and evolution of our own planet. As we continue to explore Mars, the dream of human colonization becomes ever more tangible. The red planet beckons us, promising new frontiers and endless possibilities for discovery. Mars is not just a distant world, it is a mirror reflecting our own aspirations and the boundless curiosity that drives us to explore the unknown. To understand Mars, we must travel back in time, billions of years ago, to the birth of our solar system. This journey takes us to a time when the universe was still young and the Milky Way galaxy was in its infancy. Picture a vast cloud of gas and dust, a nebula adrift in the cosmos. This nebula was a chaotic mix of elements, the remnants of ancient stars that had lived and died, scattering their material across the galaxy. This was the raw material from which our sun, planets, and everything we know came to be. Over millions of years, gravity began to pull this cloud together, creating regions of higher density. A disturbance, perhaps the shockwave from a nearby supernova, caused this cloud to collapse in on itself. This event triggered a chain reaction, compressing the gas and dust into a spinning disk. As it contracted, the nebula began to spin faster and faster, like a figure skater pulling in their arms. This spinning motion flattened the cloud into a disk, with most of the material gathering at the center. The center of this swirling cloud grew hotter and denser, eventually igniting into the star we know as the Sun. This ignition marked the birth of our solar system, a new star shining brightly in the cosmos. The leftover gas and dust swirling around the newborn Sun would eventually coalesce to form the planets. These particles collided and stuck together, gradually building up into larger and larger bodies. This process, a cosmic ballet of gravity and collisions, is where the story of Mars truly begins. Over time, these collisions and gravitational interactions shaped the planets, including Mars, into the worlds we recognize today. In the swirling disk around the young Sun, tiny particles of dust and ice began to collide and stick together. These particles, though minuscule, held the potential to create something monumental. This process, called accretion, is the engine of planet formation. Through countless collisions and mergers, these particles gradually formed larger and larger bodies. As these clumps grew larger, their gravity increased, pulling in even more material. This gravitational pull was crucial as it allowed the clumps to attract more particles and grow even faster. Over millions of years, these growing clumps, called planetesimals, became the building blocks of planets. Each planetesimal was a small world in itself, rich with the potential to become a full-fledged planet. In the region where Mars now resides, planetesimals rich in iron and silicate minerals were drawn together by gravity, forming the planet's core. This core would become the foundation upon which Mars would build its future. As Mars continued to grow, it swept up more and more material, eventually reaching its present size. This process was relentless, with Mars constantly pulling in new material to add to its mass. The process of accretion was a violent one, with countless collisions shaping the young planet. Each impact played a role in sculpting the surface and structure of Mars. The energy released from these impacts would have melted rock and generated immense heat, transforming Mars into a molten world. This molten state was a critical phase, allowing the planet to differentiate into layers and set the stage for its geological future. The intense heat generated during Mars's formation had a profound effect on its internal structure. The heavier elements, primarily iron and nickel, sank towards the center, forming the planet's core. Lighter elements such as silicon, oxygen, and magnesium rose to the surface, forming a molten magma ocean. As the planet cooled, this magma ocean solidified, creating the planet's rocky crust. Between the core and the crust lies the mantle, a layer of hot, dense rock. This process of differentiation, where a planet's interior separates into layers based on density, is a fundamental stage in planetary evolution. It is this layered structure that gives rise to many of the geological features we see on Mars today.